Mm. So beta is equal to 2b minus 2 second bright minus first dark, first bright. Second bright minus first bright. That is equal to how much will come? This is the 2 lambda d by d minus lambda d by d is equal to lambda d by d. Lambda d by d. That means this is the width of dark fringe. The width of dark fringe. Right, the width of dark fringe, right? So this is the concept of Young's double slit experiment. And also one more shortcut method I will give you. So sometimes we did not remember constructive and destructive interference. What is that path difference? In that time very difficult to get formula. So for that purpose I will use small idea. So for example here I have given already two slits. So this is the slit 1 and this is the slit 2. So from here to here the width of slit, this is the D. Now this is the central bright. So now what happened here? So on the screen, so this is the point to P here. Delta x is equal to 0, right? Path difference is 0. Path difference 0 means that is the bright region. So now here I want to consider, okay, this is S1 and S2. So arbitrary point to P dash. Alright. So now from here to here I drawn already. What is that? So path from here to here, path is how much? So S1 P dash. Similarly, if I take here, so O mean this is the P. Okay, na? So next from here to here, what is that? S2P. Correct? So now I can draw from here to here one more. So path. Right, I will give this is the O dash. So from here to here distance is how much? D. So O dash to O from slit to screen. The distance is D. Correct? So now from here to here I will consider that is the Y. Right? Y is nothing. What is the distance between? So O to P. The distance between O to P. The distance of fringe from central bright. Okay. So now I can draw here perpendicular line. So in this manner and in this manner. Alright. So here this is the theta. And this one also theta, and this one also theta. Remember everybody here, one of the most important point, that is where S1P and S2P is parallel to, yes, this and all parallel, nearly parallel, as well as here to here. What is that? O dash to O. O dash to O. S1P is parallel to S2P is parallel to O dash O. O dash O. S1P parallel, S2P parallel, O dash O. This is the, so condition, remember, is a condition. In that time only I have given previous class, S1P is equal to S1, this one only S1Y only, na? S1 or else O dash to O, that is the D I have given previous S1P is nearly equal to D. S1P as well as S2P. Correct? Like that we took condition. Here also same only. And one more. Now, what is the path difference? Path difference I will cut. And also remember S1P, S2P, O dash P. So that here this angle and this angle and this angle all are same. Parallel means same only. Na? Is a parallel means same only, right? S1P, S2P and O dash O all are parallel mean this theta is equal to same. This theta is equal to same. Okay, now path difference. Okay, this is the path difference from S1 to P, and this one I will give you. So what I want here? So P dash I will give you. P dash or else L I will give you or else Q. Okay, so where S2Q is equal to path difference, I will consider delta x. Delta x. Right? So this is the theta mean. So here angle how much will come? This is the 90. Remember everybody. This is the 90. This is the 90 minus theta. So here how much will come? This is the theta. This is how much? 90 minus theta. This is the 90 minus theta. This is the theta. This is the 90 degrees. Right. So, with the help of triangle, I will give you this name is A or else S1, S2, Q. Right. Triangle S1, S2, Q. Triangle S1, S2, Q. So, sine theta is equal to opposite side by delta x divided by hypotenuse. This is the hypotenuse man. Is hypotenuse. This is the opposite side. This is the adjacent side. This is the 90 degrees. So this is the D. Therefore, sine theta is equal to D sine theta is equal to delta x. Delta x. Okay? Delta x. So delta x is equal, now remember delta x is equal, what is that? D sine theta. D sine theta, very very important point. Dx is equal to D sine theta. D sine theta. Alright. Similarly, we know that from constructive interference, delta x is equal to n into lambda. Right. We want to consider constructive. So no need to derive. We want to consider, but no need to derive beta. First lecture, what I have given sixth part in that I have given derivation, right? Beta is equal to y is equal to lambda small d by capital D. The derivation is not required for only remembering purpose, but this one is for formula remembering purpose, not a derivation. Derivation can write completely that one 5 mark question, right? Okay. So now delta x n into lambda. So n into lambda is equal to d sine theta. D sine theta, right? So where theta is very small, therefore sine theta is nearly equal, approximately equal to theta. So therefore d theta is equal to n lambda. So theta is equal to, so what will come? Theta is equal to n lambda by d. N lambda by d. Remember this equation number 1. So from figure, so this is the y, this is the d, right? So tan theta is equal to y by d. Y by d. So here also theta is very small. So therefore tan theta is becomes theta is equal to y by d. Equation number 2. So from 1 and 2, what we can write? From 1 and 2. from 1 and 2, we can write it y by d is equal to n lambda by d. So y is equal to n lambda d by d is the nth fringe. Yes or no? Nth fringe. Yn is equal to n lambda d by d. N lambda d by d. Right? N plus 1. Why n plus 1 mean? So y n plus 1 is equal to, so n plus 1 lambda d by d. Lambda d by d. Right? So for constructive interference, this one I took there. For constructive mean bright region. Bright fringe. Bright fringe. Similarly, dark fringe purpose. Similarly, dark fringe. Similarly, dark fringe. Dark fringe. What is that? So delta x is equal to d sine theta and delta x is equal to 2n minus 1 into lambda by 2. So d sine theta is equal to 2n minus 1 into lambda by 2. So theta is equal to 2n minus 1 lambda by 2d. Lambda by 2d. Yes or no? So from figure, so tan theta is equal to, from figure, I rubbed already. From figure tan theta is equal to y by d. So theta is equal to y by d. Equation number 1, this is the equation number 2 from 1 and 2. From 1 and 2, what we can write? So y is equal to 2n minus 1 into lambda d by 2d is the yn formula. Similarly, yn plus 1 is equal to 2n plus 1. So how much will come? 2n plus 1 into lambda d by 2d. This is the, with the help of diagram. This diagram, that pattern, that process is very, very important for what purpose? Next, diffraction purpose. Diffraction purpose, very, very, very important. Right, ma? So this is the concept of Young's double slit experiment. Young's double slit experiment. First dark to second dark to third dark. So first bright and first dark. So like a difference, any difference. Some cases, so the distance between first dark of down to second dark up, the distance is equal to, we can add it only. Correct or not? So sometimes problem. So this is the central bright, is the central bright, is the first dark, is the first dark. From here to distance is equal to how much? So beta is equal to, so how much? Lambda d by 2d plus lambda d by 2d. So 2 lambda d by 2d. So how much? Lambda d by d. Oh, here also same, right? Similarly, for example, here. So what is that? First bright. Here, first bright. So from here to here distance. Correct? From here to here. From here to here, how much? Same only. So 2 first bright. 2 first bright. Yes, y is equal to 2 into lambda d by d. 2 lambda by d. Right? So like that will go. But that is the rare cases, that is they won't ask. They will ask only either only one side itself. Right? Okay. So now, very again important question. What is that? Graph. Graph between intensity and path difference. Intensity and path difference. path difference. Intensity and path difference. Right. So for intensity, intensity formula, y is equal to I1 plus I2 plus 2 root over I1 I2 cos 5. Yes or no? If I1 is equal to I2 is equal to I naught, then what would be happen? I is equal to 2 I naught plus 2 I naught square into cos 5. So get cancel. This is the 2 I naught take common. Therefore 1 plus cos 5. Already given, right? This one. So 1 plus cos 5 is equal to how much? 2 cos square by 2 cos square 5 by 2. So 2 2 ja 4 I naught into cos square 5 by 2. So this is the I. So if phi is equal to 0 degree, therefore I is equal to maximum. So 4 I naught. 4 I naught. 4 I naught. Similarly, path difference. So path difference, delta x is equal to d sine theta. D sine theta. So d sine theta is equal to lambda r. D sine theta is equal to 2n minus 1 into lambda by 2. That means, so path difference we will consider as the lambda, and path difference we can get lambda by 2 for dark and for bright. For dark and bright. Correct or not? So now we will consider graph. Is the central bright O. So this is the lambda and this is the so how much will come? First one is first dark only na, is the first dark and first bright and second dark and second bright and third dark and third bright. Yes or no? Here also is the first dark and first bright and first dark, second dark and second bright and third dark and third bright. Right. So along y-axis, I will consider intensity along y-axis. So along x-axis, I will consider. So what is that? Path difference. So path difference is equal to lambda or lambda by 2. So here what is that? Is that lambda by 2, right? Yes sir. The first one is lambda by 2. This is the lambda. Now 2d. So how much will come? 3 lambda by 2. Correct? Lambda by 2, 2 lambda by 2, 3 lambda by 2. So next, so how much of 2 bright? 2 lambda. Yes or no? Next, 4, 5 lambda by 2 and 3 lambda. Correct? Similar here. Lambda by 2, 2 lambda by 2 mean lambda, 3 lambda by 2 and 4 lambda by 2 mean 2 lambda and 5 lambda by 2 and so on. Okay. So intensity. The intensity is maximum. That means everywhere is same only. Bright fringes intensity is maximum and dark fringes intensity is minimum. Correct? 0. So that's what here. So this is the maximum. Is the I max. Mean I naught. Alright? And also here second dark 0, here again maximum. Correct? 0 and again maximum and again 0 and again maximum. So here maximum and 2d 0. Correct? And 2b maximum and 3d 0 as the maximum. So now you can draw graph. So maximum to 0, 0 to max, and maximum to 0 and 0 to maximum. So like that. Increase and decrease and again increase and again decrease and again increase, again decrease. Right. So like that graph we talk. That is the intensity graph. Are you clear? So this is the concept of a Young's double slit experiment. And also, so shape. So one more important concept, this one. So what is that? So shape of fringes. Shape of fringes. Shape of fringes. Of fringes. Shape of fringes. So first shape I will consider when the S1 and S2, when the S1 and S2 slits, when S1 and S2 are slits, okay. So that means, so this is the first slit and second slit. So like that will be, this is the S1 and S2. So fringes can form there. Fringes can form. So which manner? Right. So for example here, I will consider one cardboard like that. There is a cardboard. So slits. So dark and bright, dark and bright. So in this manner. So straight fringes. What is this? Straight fringes can form. So similarly, so when S1 and S2 point source, so that means here this is the slit. So slit is nothing but, for example, so what we can consider one cardboard like that one. So now we want to draw slit in this manner. So that is the slit. So small slit is a cardboard. So we will we will do some slit. That is the slit. So now point source means we want to point source. So circle. So in this manner is the S1 and S2. So now we will consider on the screen. So how the shape will come? Right, central bright. The central bright. So like that one we can form. And here, so can form hyperbola shape. Hyperbola shape can form. So the shape of fringes is hyperbola. When they are point sources. They are point sources. Right. Last and final. So When the S1, S2 horizontal, when S1 and S2 horizontal, so horizontal, that means, so this is the S1 and this is the S2 slit, S1 slit and S2 slit, S1 and S2. So screen here will be there, screen there will be there. Then how it can form? Then how it can form? So that we can consider, right? Here one fringe, and again here also one fringe. Here is one fringe. So now we can draw. So right. So then what happened here? Circular fringes can form. Circular fringes. Circular fringes on the screen. So what can form? Circular fringes. So this is the S1 and S2. S1 and S2. So here screen I will consider in this manner. So horizontal, this is the horizontal. So light rays are moving in this direction. Is the central bright. Central bright. So here. So circular shape. Circular fringes can form brighter, darker, fringes. So circular fringes can form here. Hyperbola. Fringes can form. Alright. So this is a concept of Young's double slit experiment. Complete over. Okay. So now we will discuss very important concept, that is the diffraction. Right, very important. Another question. So problem point of very important this one. But yesterday question, so some cases will come, some cases won't come. But problem point of view, this concept is very important. Right. What is the meaning of diffraction? What is the meaning of diffraction? Diffraction is nothing but so this is given by first time. The scientist name is, so in 17th century, Grimaldi. What is his name? Grimaldi. Grimaldi is discovered that if the size of obstacle or aperture is comparable with the wavelength of light. Wavelength of light. What does that mean? Right, you can observe once. So, according to rectilinear propagation of light, if an opaque obstacle or aperture is placed between source and screen. Source and screen. For example, this is the source. Okay, this is the screen. Now here I can keep one of obstacle. Or else. So this is the screen, this is the source, and here I can keep one of a aperture. This is the obstacle. I kept like that one. This is the aperture. This is the obstacle. So light always can travel in the straight line. Correct or not? In this direction. But obstacle will be there. Then, so the source and screen, a sharp shadow or an illuminated region is obtained on the screen. For example, here. So then what happened here? So like that. So in this manner, that means here what can form here? So this is the dark region can form. Is the dark region on the screen, and above the dark region, what can form here? Illuminated region can form. What is that? Illuminated region can form. So this is the dark and here illuminated region. Similarly, opaque aperture is the aperture. The light is passing in this direction. Correct or not? Aperture. So then what happened here? So up to here to here, this is a completely bright region. So this is the dark region. Is a bright region. So above the bright region, up the either side. So what can form here? So dark region can form. Dark fringes can form. Dark bright fringes can form. So what is that? According to rectilinear propagation of light, if an opaque obstacle or aperture is placed between source and screen, so a sharp shadow or illuminated region obtained on the screen. This is the observed by very important famous scientist, that is Grimaldi. Grimaldi is done in the 17th century. So he observed very important by here. So one condition will be, what is that condition? If the size of obstacle or aperture, the size of obstacle or aperture is comparable with the wavelength. That means, so this length and wavelength of light, very small, right? Wavelength of light very small. So now this size is, wavelength of light I will consider lambda. This size I will consider, d is a greater than. That means lambda is greater than d, or else d is smaller than of lambda. In that case, we can observe one phenomenon. What is that? So the bending of, the light deviates from rectilinear propagation near the edges of obstacle. That means the light can deviate. For example, in this manner. The light is moving in the straight line in this manner. Okay, then what happened? It can moves in this direction and in this direction. This is a straight. Okay, it is a straight in this manner, so it can move in this manner. It can bend. That bending property, this property of bending of light waves around the edges of small obstacle or aperture is known as diffraction. This is the observed by Grimaldi. Right? So Grimaldi. So next slide I will give you more and more information. Next slide I will give you. Alright? Thank you to one and all.